Do I need to talk in the mic? I don't need to. I can also just...
It's better published from that.
Oh, is it? Okay, it's better. Okay, cool. Hello, good morning to everyone. I'm going to be talking to you a little bit today about the inter-blockchain communication protocol from Cosmos Network and how we envision an interoperable future over that. So first, a little bit about me. I'm actually relatively new to the Cosmos ecosystem. I joined in March of this year. Prior to that, I was working on a project in the DeFi Ethereum substrate ecosystem. Working in DeFi for a while obviously had its pros and had its cons. And after a while, I thought it would be nice to shift a bit lower down on the infrastructure level. So now I work on IBC. I'm primarily acting as the IBC product lead at the moment. I also do some work on the grants team and dev roles, but in the IBC focus. Prior to joining crypto, I had some training in intellectual property law, which is coming surprisingly handy these days. So first, as we all know from the Ethereum ecosystem, one of the most valuable system design principles is composability. In Ethereum, this has really been embodied in the smart contract system. And we've seen it explode in the last few years, and particularly in the last year in the form of DeFi and the power of financial Legos. All of this means that a lot of value has been driven not only in monetary resource, but as well as in people who want to build on Ethereum, and also people who recognize that there are limits to the amount of transactions and just scalability that the Ethereum ecosystem is providing at the moment. So we've also seen, and I think everyone has seen in the course of this conference, that the interchain ecosystem has also become a hot topic. All the other blockchains want to build a bridge to ETH. ETH people are really interested in how they can leverage the power of other blockchains and also layer 2 solutions to kind of extend scalability of Ethereum transactions. A lot of approaches that I've seen at this conference and in the larger ecosystem is to build bespoke bridges to Ethereum. And a lot of these projects want these bridges to allow extension of ETH composability, these financial Legos, these native primitives, to their chains and their ecosystems. However, there are a lot of challenges with running bespoke bridges. Running a bridge can be as complicated as running another chain. A lot of bridges have their own validator sets, and you have to define governance structures. You have to worry about how messages are actually passed across. Having a bespoke bridge from every single chain to Ethereum and to every other chain also seems to be hugely redundant and also increases the complexity of transactions if you can imagine a multi-hop interoperability. So I want to talk to you a little bit today about what we think this kind of extension could look like and what DeFi Legos could look like with a space in between chains, in between all of these pieces, where not everything is on the same state machine. So I want to show a quick video right now of, of something of a DEX that is live on Cosmos at the moment. I think most people here are familiar with Uniswap, and what I'll show you is what it looks like when you're making a token transfer between, or a token swap between two different tokens. In this case, however, we're not interacting with a number of smart contracts, but we're actually interacting with a number of different sovereign blockchains. And so the first thing you'll see is whenever a token is transferred through through IBC to become part of a pool that is then able to be fungible with all of the, or transferable or swappable with all of these other tokens. You'll also see Kepler, which is the Cosmos MetaMask. The main difference is that you'll see in Kepler all of the different chains that you can interact with as well. So it's like, it's an interchain wallet and signer. And yeah, so I can do that. Yeah, so this is the landing page for osmosis, which is what the DEX is called. Yeah, here you can see we're connecting our wallet. This is Kepler. It's our little dev wallet. You can see a number of other things you can do on the wallet besides swapping. You can directly send an IBC transfer. You can stake on different chains to receive APY. Cool. Now I've transferred. I'm going to deposit this number of AKT to osmosis, the DEX, so that I can, from the DEX, make swaps with other tokens. I don't know if you saw, but the transaction fee for that was like 1 cent. Pretty cool. Cool. Now I can click through, and I can actually see my IBC transfer on MintScan, which is the block explorer for IBC, or one of the block explorers. You can see it's been transferred over a specific channel. Map of zones is our visual explorer for all of the different connected IBC zones at the moment. Obviously, this number is growing all the time. But here you can see, okay, now on channel 9, I've transferred through to osmosis, 20 AKT. Now I'm back on osmosis, and I can see I have 40 AKT as opposed to the 20 I had before. Now I want to make a trade. And I want to get Atom, which is obviously the native token for Cosmos. You can check your slippage fee and how much tolerance you want, and then we make a swap. You can also see that slippage is pretty low on osmosis. Transactions are broadcasted and carried over to different chains through relay infrastructure, which in this case is run by osmosis, but can be run by anyone, actually. You can spin up your own relay. Cool, now you can see the tokens have been transferred or swapped, and now I have more Atom. And now I want to take the Atom from Osmosis Hub back into my wallet. Checking the Explorer again, I can see that the transfer has been made successfully. 10 Atom back into the Cosmos address. And so this is my wallet address that Kepler has registered. Takes a little while for the UI to refresh. Okay, 2 Atom left in Osmosis, and I have 21 Atom now in my wallet. Yeah, so that's the brief little demo. I wish I could have done that live. Unfortunately, I could only do this video. But yeah, that's kind of what we envision an interchain transfer to look like. And it's live now, and you can play around with it. Another DEX is going to be launching at the end of the month, which with a pretty cool UI as well. So. Yeah, so now that we've gotten that little kind of show about what it looks like in a user interaction format, I want to talk a little bit about what is actually the protocol. So IBC is, there's been a cool metaphor that one of the core contributors to the ecosystem, Sunny Argal, said about what IBC is like. And if you go to if you go to any dock or if you go to any harbor, you'll see a lot of different containers, shipping containers. All of these containers are pretty much the same dimension. They're uniform in size. You can't actually tell from the container what is inside. It could be anything from, it could be tokens, it could be sushi, it could be whatever you want. But In any case, all of the logistics providers across the entire world know what to do with these containers when they see it, because they have been standardized. And so when we think about IBC, we can imagine it as a kind of standard, a set of abstractions, a protocol that defines what dimensions these shipping containers should be. IBC doesn't really care about what's being transferred over the wire or what kind of messages are inside of these boxes, but it does define for you what size those boxes are and how each person or each dock on each side of the transfer can handle them. So what we can see, as we saw before, is that IBC is live now. It launched in March of 2021. And as of right now, there are 9 active zones that are connected. A lot of these zones have already thriving ecosystems of their own, Crypto.com, Terra, Iris, but having access to IBC and the power to make interchain transfers allows them to also access ecosystems that are bigger than themselves. And so, if you have an ecosystem which is focused a lot on creating reputation or creating identities, but they don't have maybe as much work on making on DeFi or allowing their users to access a kind of DeFi business model, they can just simply connect to another zone and not have to bootstrap an entire multitude of ecosystems that way. They can directly bootstrap through something like IBC. All of this is supported, the protocol layer is supported by the relayer infrastructure. And what I mentioned before is that these relayers you can imagine as the logistics providers. So they are the ones who are actually shipping the containers back and forth between the different chains. How that works with something like osmosis, a token transfer, is that on chain A, you would have these tokens. Chain A knows X user has Y number of tokens. Chain B doesn't know about the user, but it does know that IBC will tell it, like, we'll be able to ship these tokens over. It has an idea of what a fungible token is. It doesn't know, however, how many tokens Chain A has. Chain A then sends a proof over IBC and over this relayer infrastructure, which contains, okay, this user does have these many tokens, and here's a proof to show it. Now Chain B recognizes that, and it's able to know that the tokens are escrowed on Chain A and then mint the corresponding assets on Chain B. So something like this escrow model is what works for fungible tokens, but obviously IBC is not only limited to fungible tokens. It's quite generic. It can carry any kind of message from governance proposals to NFTs as well. What IBC is this set of abstractions. So it doesn't actually determine any kind of security properties that you need to have. Those are determined by you, and it can be determined by the base assumptions of the chain. And so there are really no trust assumptions. It can do async or synchronous communications. It can do timeouts. The bottom line is that IBC has been built for the most adversarial environment, and that is for dynamic topologies, for dynamic validator sets. It doesn't rely on something like a shared security model where you have a relay chain or a beacon chain telling the shards, okay, this guy's okay, this guy's not, but it really tries to make as few assumptions as possible. And this is enabled through the handshake system that IBC has for establishing channels between the different chains. It's been modeled a lot off of TCP/IP. As I said before, chains like ETH 2.0 or models like ETH 2.0 and Polkadot have different assumptions about shared security. The base assumption there is that there is a fixed topology for the validator set, and that the master set knows the validator set and can assign validators. And so you have this idea of a logically centralized control plane. IBC doesn't make that assumption. And moreover, compared to other bridging protocols like NEAR or Optics, IBC also doesn't have an innocent until proven guilty kind of mindset. It really is coming from a more security-focused mindset of, okay, we want to make sure that both chains are, that this connection we have will really be trustworthy. I think that there are a lot of possibilities and potentials for ETH 2.0 and scalability and for Polkadot and the kind of like idea of shared security. But I think the main issue that we've seen with that is that private or permissioned blockchains, which will be regulatory or enterprise blockchains, they won't be able to participate in these kinds of public networks because they need that kind of control on their validator set. So they can't give up the kind of like centralized control plane. So if we imagine a blockchain world that includes enterprises and governments and all of these other regulatory bodies that we ideally would maybe like to see participating in this world, it won't be possible to have everyone on a single chain. ETH 2.0 can handle things like inter-shard communication quite well, but it's not mutually exclusive from using something like IBC to communicate to chains with other types of security assumptions. So in an ecosystem topology where there are some blockchains with sharded and shared validator sets and some blockchains with not, IBC seems to be the most logical way to work with all of them. And it can also work with no validators at all. That's what we run our testnet on. So there are a few benefits to interoperability over IBC at large. The first one obviously is costs. We all know that gas prices can be quite exorbitant, and we've all seen now in osmosis that the gas prices are quite low and can be zero if the chain decides. The second is transaction standardization. So like the shipping container metaphor, we can see that standardizing communication provides us with a lot of efficiency positives. If we don't have every single bridge and connection in a bespoke way, we can have really clean, extensible, and well-understood standards to really extend the composability that we've seen in the ecosystem to every ecosystem. IBC also isn't just a low-level protocol. We can imagine it really as a platform that people can build extensions on top of and more application-level protocols that we can understand formally. And then composability might look a little bit more like the internet that we know today. So if we extend the TCP/IP metaphor, you can imagine if IBC is TCP/IP, then the application layer can also be built on top. HTTP for websites, FTP for file transfer, SMTP for emails, all of these. Now is the fun time for application-level protocols to be built on top of IBC in very similar ways. The third benefit is this idea of account abstraction or standardization. So one of the features we're working on now as part of the application extension of IBC is something called, we've been calling interchain accounts, which is a way that two blockchains can have actual accounts on each other's chains, two contracts, two accounts that interact with each other. And this really reproduces composability in a way that other bridges also don't support at the moment. So we can imagine really cool use cases for this, anything from governance to token distribution to DAOs. This is what we're also trying to enable over something like low-level IBC. The fourth major benefit is fault isolation. So in a system like ETH, a bug in any of the smart contracts means that all the contracts that touch it could be at risk, could have funds lost. Obviously, a bug in a compiler has the same effect. And in the Cosmos network, every chain is independent and sovereign. They're communicating over something like IBC, but failures are isolated in the individual chain level. And so if you look at the ecosystem at large, you can see that it can be more rigorous and more fault tolerant. If one blockchain fails, the other one doesn't necessarily need to be at risk, and the funds aren't necessarily immediately lost. Another cool thing about this is the ability to experiment. So upgrades can also happen at a blockchain level. So you can really have a lot of experimentation on one chain, but without putting the other ones at risk. And obviously the last benefit is really just having this kind of diversity possible. You can have chain sovereignty and tailored products on the chain level. Something like what I mentioned before, where privacy is really important for the users of one chain, but maybe reputation and public identity is equally as important. Both of those can coexist and still communicate in a way that doesn't necessarily limit the possibility of the other. So what's actually needed to implement IBC? I've been to a few talks at this conference which talk about the complexity of implementing IBC and how it's really only tailored for the Cosmos SDK or Cosmos chains. And I have to say that that's actually just not true. I can kind of understand why that seems that way from the outside, because currently the default implementation out of the box is IBC Go module, which is working for Cosmos SDK, and the Tendermint Lite client. But actually you can implement IBC in all different kinds of ways. And because, again, IBC is really just this set of abstractions. So what you need is to implement the core logic, This is transport authentication ordering. It can be implemented in any language. As I said before, IBC Go is already there and working. IBC Rust is in development, and IBC Solidity as well. And XYZ, etc., other possibilities are there. The great thing about IBC is that it's already specified as well, and the specs are verified and public. So that means that anyone can take those specs and implement their own version of that core logic. The second aspect that's really important for implementing IBC is a light client. So there are a number of different ways that people understand what light client means. What we mean is that it's a client which connects to a full node and requests new block headers and verifies that those headers can be trusted. And so the default light client for IBC at the moment, or the one that's been fully implemented and working, is Tendermint. So in an IBC connection, you'll have Tendermint light clients on one chain instance and also on the other, and they understand each other's state machine. Grandpa, however, is also being developed at the moment, and what's really exciting for me is the development of a WASM upgradable light client system. And so this is more of a WASM environment where if you want to have more rapid iteration on your light client, then you'll be able to just deploy new versions of that in the WASM environment. And that's what we're working on with Silo at the moment. So, and this one is not as generic. The last one is the application level module. So for example, something like a token transfer, both chains need to know what a token is and what to do when that token arrives. So those kinds of messages and those types of handlers on a chain level should also be implemented for IBC to work appropriately. So just a quick review of the interoperability benefits: standardization of interfaces. This is the packet types, message types that we were talking about. Rather than having a bunch of bespoke implementations, we have this more formalized, easy to understand way. More diversity, reducing the cost of sovereignty, less fragility due to fault isolation, and easier coordination, because at Cosmos we believe that an ecosystem that speaks the same language or can understand the same language is just easier to coordinate in versus an ecosystem that's founded on a bunch of different bespoke solutions. So I do want to talk about this elephant in the room, which is about standards at large. Obviously, there are a lot of different projects who are building a lot of different standards. We don't want to get into the solution where we have 15 different standards. We all want to communicate or cooperate together, but we don't know which language to talk. I think right now, in the current situation, it hasn't gone to this point yet. And that's why I want to bring this call to action, that we should figure out this interoperability thing before we get to this point. I believe that there are a lot of different positives and negatives for each type of bridge proposal that I've heard at the conference. But I want to just bring across the point that I don't think that in any of these cases, they are mutually exclusive with the IBC approach, due to what I've talked about before, due to the fact that it is this generic set of abstractions. It is super customizable. It does assume the largest variety of security assumptions. And what we can see is that a lot of projects are trying to work together across ecosystems, and interoperability, interchain is this huge buzzword right now, but people are still speaking different languages, coming from different backgrounds, from different industries, having different user bases. And so we can see that right now is the perfect time to talk about how to make interoperability standardized and how to make this kind of language that we speak the easiest to understand for everyone. We can gloss over a lot of these issues also with over-collateralization or insurance or all of these things that happen in traditional finance, but we can also just drill down and formalize models of interchain communication right now. And so, in our opinion, IBC provides the simplest and least opinionated approach to formalized processes and formalized communication by enabling these state machines to communicate really arbitrary messages to each other in a very standardized way. And this will fundamentally lower the cost of interoperability and lower the cost of sovereignty across the entire internet of blockchains. So, thanks. I'm open for questions.
Hi. What is the throughput and the latency between the chains when you're talking about the message transport?
IBC doesn't really have any. I mean, I guess you're talking about like transactions per block kind of vibe, or.
More of the arbitrary messaging that you're talking about, like maybe transferring entities, for example. Yeah, a bigger payload. Is there concerns about flagging the network, slowing latency between going from A to B?
I think so. There are two ways that channels can be configured at the moment. One is ordered channels, where you might see this kind of queuing, stacking up of transactions. The other are unordered channels, and so these channels, that would be more like a mempool vibe, where you have relayers who would be able to, if there's like a higher fee incentivization attached to a message packet, for example, they might say, okay, we want to relay this first. So it's really up to the chain, depending on what kind of channel they want to establish. Yeah.
Hi. Yeah, I wanted to know, is there a protection mechanism for a denial of service kind of attack on IBC? Because I figured that what you have interacting is always contracts on the different networks, and you could send like packages just making you do random calculations and just denial of servicing you. Do you protect that? How do you handle that?
So there are fees associated with transactions at large. I mean, I think this is a standard mechanism. Obviously, a chain can decide we don't want any fees, and then they would expose themselves to that. But yeah.
Hey, I'm sorry if it's kind of a basic question and not directly IBC related, but can you give the intuition around, let's say I have a token that lives on two different chains. What's the mechanism to make sure that there's no duplication? Like if I send it from chain A to chain B, like how does chain B make sure that it doesn't exist anymore in chain A?
So whenever a token transfer is conducted, you'll, along with or in the transfer process, you have to send a proof that, like, let's say if it's a token transfer, that those tokens have been escrowed on chain A. Moreover, actually, in the denomination of the token, when a token makes one hop over or between chains, that channel and port that has made that hop over will be prefixed to the denomination of that token. And so you'll see, rather than like osmosis, you'll see like IBC/channel 9 port 100 osmosis. And we do that because we want to protect against this, like where you have one token coming over one channel that has a different security guarantee than another channel. We want to prevent cases like that of those two tokens then being fungible. So.
Sorry, just to follow up. And if chain A, let's say, has a weaker security model and ends up rolling back, then do you rely on trust between those two chains, like chain B kind of trusting chain A, like through governance, or how does that work?
You mean like if your tokens are lost on chain A, does that mean they're lost on chain B?
No, more like if I send it from chain A to chain B and then exists on chain B, but then I roll back on chain A because let's say I have like centralized validation, and then I can just put whatever state I want. Like, do you rely on some kind of governance decision that chain B says, okay, we're happy with the model in chain A, we're happy to trust their security, and then just rely on the escrow?
Yeah, so Cosmos or the IBC protocol doesn't make any kind of dictation towards how chains need to behave in that ecosystem or in that situation. I think what we've actually seen in practice with IBC ecosystems is that you end up having, let's say, 3 or 4 chains which have very interoperable products, and or maybe their user base is all in, China, South Korea, India, and they have a lot of market overlap. And so those ecosystems and those chains then tend to interoperate with each other. And whereas, you have other chains based with different user groups that have the same kind of action. So I think there is it almost defaults to how things work in the real world, where you have companies and or groups of people that trust each other and do business. Yeah.
So this is a kind of follow-up question to the previous one. So is the escrow mechanism part of the standard, or is it delegated to the particular chain? I'm asking because some chains, for example, Ethereum, can handle completely trustless escrows via smart contracts, whereas chains like Bitcoin cannot. So is the escrow mechanism part of the IBC, or is it just some abstraction that, here you verified that the escrow has happened? And
So the escrow is part of ICS 20, which is the IBC standard for fungible token transfers. Yeah, and so, but I mean, I don't think I know enough about how, for example, the Bitcoin mechanism works to answer whether or not that spec would cover that use case you're talking about. But yeah, the spec does handle, like in this specific case of fungible token transfers.
I wanted to ask, how does Atom and the token on a token economics level benefits from all of this? Because, of course, on Polkadot, for example, you have all the parachains, auctions, and all the lockups for all these new chains. As a holder, I'd like to know how Moon.
Yeah, so that's a really good question. Atom has obviously at this point been used largely for staking, for the validator set for the Cosmos Hub, and for governance proposals being passed on the hub. Up until quite recently, there wasn't as much activity there, but I think you'll see that there is going to be a lot more activity starting with the launch of the Gravity DEX on the Cosmos Hub. And I think the wider vision for the hub is, so maybe like to back up a step, the hub is a type of infrastructure that we envision for the Cosmos ecosystem where rather than having IBC connections between every single chain and every chain needed to then establish clients, for example, with every other chain, they can connect to something like a hub, the Cosmos Hub, which has, as you could see, like at least nine different, or all the active zones are connected. And so once you connect to the hub, you can then connect further to all of the chains that are connected to the hub. So what we see the hub as developing towards is a kind of a gateway for products and for assets that really want to flow easily between different chains. So Osmosis right now passes also through Atom. The Gravity DEX, which will be launching on the hub natively, will also offer a very nice AMM model with batch transactions for basically lower like smaller bag liquidity providers. And a lot of these products and features that we're trying to build out on the hub right now are what we envision will be also largely deriving value for Atom holders, in addition to obviously the staking rewards that you get. I think another aspect of development, which I'm very excited about for Atom holders, is liquid staking. And so the ability to get staking derivatives across multiple chains. Yeah.
I have a question in terms of UX-wise. Obviously, like you said, there's a ton of different bridges right now. But the UX of kind of a user having to use a bridge and then use a dApp is pretty terrible. How do you kind of envision the IBC working in terms of, or improving UX-wise of using dApps on different chains and all these things?
I don't know if you were here for the first part of the talk where I demoed the current DEX. So it's, I can also show you again later. You could also look it up yourself, it's live. But actually, the user experience is extremely similar to Uniswap right now. All of the kind of interchain transaction can be completely abstracted away from the user, depending on how good your front-end devs are, I guess. But yeah, I think like the Osmosis DEX has really shown that the user experience for using IBC can be really great. And you can make interchain token transfers as easily as you do in a single chain.
Okay, so essentially abstracting the aspect of the bridge by just directly using the dApp.
I mean, we're still using IBC, and we're using all of the infrastructure, but the user does not need to know any of this is happening.
What happens in case of a fork? Like if one of the blockchains forks, and now there's two versions of that, which version would the bridge connect to?
I mean, I think in this case it would be similar to the governance question before, where, I mean, each chain should decide what to do on a governance level with their counterparty chains. Like the IBC doesn't tell you how to handle this kind of situation. I think also it makes sense because every chain would handle it potentially differently depending on what kind of fork it is as well.
Anyone else? All right, thank you.